Let's start with a simple program. 1 factorial plus 4 factorial plus 9 factorial plus what will happen? 16 factorial plus next what should it be? Yes, 25 factorial plus next 36 factorial plus dot 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 and so on up to what? N will be entered. Then what if n is entered? See, 1 factorial, that is okay. 4 factorial, 4 is 2 square. 1 is 1 square, 4 is 2 square. 9 is 3 square. 16 is 4 square. 25 is 5 square. 36 is 6 square. So next is 7 square, 49 factorial. Next is 8 square, 64 factorial. So definitely the next one is n square, then the whole factorial, n square factorial. Is not it so? So we have to, if n is inputted, we have to calculate 1 square factorial plus 2 square factorial plus 3 square factorial plus 4 square factorial and so on up to n square factorial. So this program should be very easy. If I think that I will have to calculate the factorial over here, then it might be again difficult. But a function, use of a function will help your cause. Like if I ask for from the user n firstly, which we should always do, printf enter n, and then I scan that value of n, and then I will start from I. Let me scan it first. Scanf %d ampersand n. Then I will start from I and continue up to n. So for I equal to 1, I less than equal to n, I plus plus I should move. What does this mean? This means that when I enter with I equal to 1, I need 1 square factorial. When I enter with I equal to 2, I need 2 square, that is 4 factorial. 2 square factorial, that is 4 factorial. When I enter with I equal to 3, I need 3 square factorial, that is 9 factorial. When I enter with I equal to 4, I need 4 square factorial, that is 16 factorial, and so on. Which means that I will need factorial of I into I. Please understand this. If I have a factorial function, then I can call that function and pass on the value I into I. Please understand, I square factorial. When I is 1, 1 square factorial. When I is 2, 2 square factorial. So this can also be done. You pass on this I into I directly to the factorial function. The factorial function will receive the value because I into I is computed and then passed on as an argument. Please understand, when you are passing on I into I, you are passing on I into I as an argument. It will be computed first and then will be passed on as an argument, which will be received in the factorial function. So then I can receive this factorial function output. The output of this factorial function will be returned over here. What can I do with it? I can assign it somewhere, or without assigning it, what I can easily do is I can directly add it. That is, the sum will be sum plus equal to this. The factorial I into I will return 1 factorial or 4 factorial or 9 factorial or 16 factorial or n square factorial at the end. So that has to be directly added to sum. So sum plus equal to fact I into I, and then you can easily print the sum. See, your program becomes so easy. You just need to add the factorial of I into I with sum. The factorial of n, such a function has to be written separately. And remember that n has got no relation with this n. If I receive int fact int n, then int fact means it will return an integer, and receive an n means it will receive this value n. And it receives the value n means simple that this is the value, it receives the n means the parameter n means that n is a new variable, has got no relation with this n. Anyway, printf, I print the sum of the expression is %d. %d what? %d sum. Okay. So let me now run the program, but factorial function needs to be written. Fact function is not there within this math.h. Math.h does not contain fact function. Like in the previous program you saw, without writing the pow function I can run this program, because math.h header file contains the pow function already. So you can call the pow function from math.h without being concerned that you need to write pow function separately, because pow function is already there. Fact function is not there. If you run it, it will ask for the prototype. See, firstly n and I undefined, that you must define, that you do firstly. Int n comma I comma sum, that you definitely need. But if you run this, still there will be one error, because fact should have a prototype. Understand this? So fact should have a prototype means you must write fact function yourself. Math.h does not contain. So math.h you can avoid hash including in this program. You can avoid. Is not it so? Anyway, int fact, int n you receive. And then what you do? What you do is again a for loop for calculating the fact. For I equal to 1, comma product equal to 1, I less than equal to n, I plus plus, product into equal to I, that is product equal to product into I. That's why you start from product equal to 1. So firstly 1 you multiply with that 1, then you multiply 2 with that 1, then you multiply 3 with that 1, and so on. Okay. Now do you notice one thing, that we have written fact function so many times prior to this, but I want to tell you one thing, that here you could have also started from 2, because if n is 1, then product will always be 1. Product you are initializing to 1. So if n is 1, factorial of 1 is 1. In any case, what will you return? You will return product only. You are going to return product. So consider, suppose n is 1. If n has been sent as 1, you start from I2. You initialize product to 1. 2 less than equal to 1, n is 1, I is 2. 2 less than equal to 1 is false. It breaks out. Return product means product is 1 initialized over here. You return 1. So for 1 you are returning 1. But when I, suppose n is 2, you start with I equal to 2. 2 less than equal to 2 is true. So it will enter and multiply 2 with it. If it is 3 still, it will enter and start multiplying. So every time it will start multiplying for 2, and that is what you want. Why you do this? Because extra iteration of the for loop you avoid. If n is 1, then you avoid iterating it at least even once. If it is 2, then you are iterating only one time, because you are starting from 2. If it is 3, you are iterating 2 times. You don't need to go through the loop 3 times. You don't need to multiply 1 with 1 for no reason. I think you got this. This program should run absolutely fine. Anyway, you need to declare all these variables. So int I and product, these are the two variables used. N you need not define separately, because n is this, n has been defined over here only. You have declared int n and received the value. Over here only you have declared int n and received the value. So n does not need to be separately defined. We have not done it in whenever we start written function, we have not done it, because we are declaring here only. Okay. But your returning product means you are returning an integer. So what is your return type? Your return type is integer. So let's run the program with, say, 25. 1 factorial plus 2, that is 4 factorial. What does that mean? 4 factorial is 24, and 1 factorial plus 4 factorial, 1 plus 24 is 25. You can run for 3 also. What happened? Minus is not possible. See what happened. I will show you what happened. 3 means 1 factorial plus 4 factorial plus 9 factorial. What is 1 factorial? 1. What is 4 factorial? 24. Now what is 9 factorial? Please calculate. See, 5 factorial is 120. So 6 factorial is 120 into 6. What is that? 720. So what is 7 factorial? 720 into 7. What is 720 into 7? 4900 plus 140. That is 5040. Sorry, very sorry. We'll just write over here. Anyway, so 720 into 7, what is that? 70 into 7 is 490 and so it's 4900, and 20 into 7 is 140. So 4900 plus 100 makes it 5000. So definitely it is 5040. Now if you multiply 5040 with 8, what happens? Something of the order of say 50 into 8 is 400. So 5000 into 8 makes it something around 40,000, more than 40,000. Now what is the number that is allowed in C? Maximum number, if you remember, 32767. 40,000 is more than that. That's why it is showing a garbage. So 9 factorial is never possible. So should I take this opportunity to teach you something new? What new? I can take this opportunity to teach you that there is something called the concept of long. Long means if you declare long int A, like you declare int A, if you declare long int A, then A will be declared using not two memory locations, which normally happens in any integer. In any integer, what happens? Two memory locations. If you declare long int A instead of A, then it will be declared using 4 memory locations. 4 memory locations means how many bits? It means 32 bits. So this time it can actually compute up to 1 1 1 1 and so on. This one how many times? Up to 32 times. That is, this number, up to this number it can accommodate. What is this number? See, 1 1 1, 3 ones is 7, 2 cube minus 1. You check this. This is also something new. 1 1 1, what is that? 7. What is 7? 8 minus 1. What is 8? 2 cube. It is 2 cube minus 1. Check this. This is 2 cube minus 1. If you write 1 1 1 1, 4 ones, what is this? It is 15. 1 1 1 1 is 15. What is 15? 15 is 16 minus 1. What is 16? 2 to the power of 4 minus 1. You see this? If it is 1 1 1 1 1, what is this? This is 31. What is 31? 32 minus 1. That is 2 to the power of 5 is 32 minus 1, 31. You see this? So if there are n ones, 5 ones 2 to the power of 5 minus 1, 4 ones 2 to the power of 4 minus 1. In this way, if there are n ones, it is 2 to the power of n minus 1. Is not it so? So if you can write up to 32 ones, then what is this number? 2 to the power of 32 minus 1. But this bit is the sign bit. So 0 is positive. So this bit is not magnitude, this is sign bit. 0 is positive. So how many ones? 31 ones. So what is this value? 2 to the power of 31 minus 1, which is a big number. So up to 2 to the power of 31 minus 1 you can accommodate if you write it as long int. On the contrary, if you write it as int, I will show you. If you write it as int, when you write int A, I had been till now telling you that you can only accommodate up to 32767. Why? I will show you now. Say you write int A. If you write int A, what happens? A is only how many bits? How many memory locations? 2 memory locations. So A will be declared using 2 memory locations. 2 memory location means how many bits? Each memory location 8 bits. So how many bits? 16 bits, out of which the first bit is 0 indicating sign. After that 15 bits. After this we have got 15 bits. So what is that? That is 2 to the power of 15 minus 1. That is the maximum number that is allowed. 2 to the power of 15 minus 1. What is that? 2 to the power of 15 is 32768 minus 1. What is that? 32767. I told you that integer can accommodate up to 32767. Why? This is the reason. Because int is declared using 2 memory locations. 2 memory locations means 8 plus 8, 16 bits. So 16 bits, first bit 0. So 15 ones, up to 15 ones is the maximum number. So 15 ones is 2 to the power of 15 minus 1. What is that? 32767. But if you declare long int a, it's a new prototype, then long int a will take 32 bits because 4 memory locations will be allocated. And 4 memory locations means 32 bits. First bit 0 indicating sign positive. After that 31 ones. So the maximum number is 2 to the power of 31 minus 1. A huge number. Now this program should run absolutely fine. So what to do over there? Over here we can do one interesting thing. That is, we declare I as integer. It is as simple as that. You can declare I as integer because I will only go up to n. See, n can be integer. N is 9, n is 16. It's an integer. Two memory locations enough. But the factorial has to be long int. So let me declare this product not as integer but as long int product. We can do that. If we do that, now the product can accommodate up to a big number. So 9 factorial will be possible now. So this product you are returning means, what are you returning? You are returning a long int. So this return type will not be int but will be long int. And you can understand now this long int is being added to sum. So sum cannot also, the sum of all this cannot also be an integer. Sum also has to be long int. Long int means 4 memory locations it will take. Now you can print it. It should work fine. Is not so? But if you run this program, should it run? Check for once. Sorry. This has to be commented out. So many things you have written. It must be commented out. You can comment up to this. So rest of the program is fine. Let me run it. Enter n. If I say 2, it is absolutely fine, 25. If you say 3, 9 factorial, again minus. Why? Because over here you have printed sum as %d. Though you declared it as long int, but d is decimal. D means 2 memory locations. So sum is not %d, sum is long int. LD. Sorry, 2 runs fine. 3 runs fine again. Long int. What did you do? You have only changed. You can check that the number is working absolutely fine. You can check that you have declared this sum as long int because the sum will be huge. You are using 9 factorial, sum will be huge. Your n will not be huge because n is only up to maybe up to 16 factorial or 4 factorial or maybe 5 factorial you will enter. So n is not huge, n is int. I will go only up to n. So n is I is also int. But your sum is the sum of all these factorials which are huge numbers. So declare sum as long int. And when you print this sum, print it as long int, not d but ld. Similarly, when you are calculating the product, calculating the factorial, it is important that you declare it as long int and receive the factorial over there. And when you return it as long int. So it is always good to have the factorial function prototype defined like this, long int. Could you understand? You have learned a new data type in the process, which is a new, what is this data type? This data type is long int. I think you understand this. So in this you have learned that factorial is a function. What are the things? I summarize what you have learned. You have learned that while sending an argument, you can send expressions like this. These expressions will be computed and sent, which you receive over here. When you receive the computed value of I into I and you calculate. And another thing you have learned is a new data type called long int. We'll return with this program itself. The screen will be exactly this when we return, and we will write a similar program where I will not write 1 factorial plus 4 factorial plus 9 factorial and so on, but these values are going to change. I will show you when we come back. Let's come back after a little break. Thank you so much.